Hello, everyone. Good afternoon or morning or evening, depending on where you are around the world. Want to welcome you to our webinar on towards carbon neutrality in higher education. My name is Tim Carter. I'm president of Second Nature. We're so thankful that you're here joining us. I'll introduce our panelists and speakers in a second, but first wanted to go through a few housekeeping pieces here as we get started. We are recording this program, so after the session, we'll send out a link so you can watch it again and share it with your friends and colleagues. We'll post it online at secondnature.org. You can also ask questions, and we would encourage this. We're going to have a conversation throughout the afternoon here. So in the chat function or the Q&A function, write your questions in there, and we'll be able to address them at the end of the session. And just make sure you know you're on mute mode, so don't try to talk. We're not going to hear you anyway. I will say one thing, because this is conversational. Eric, you can change the next slide. You may want to just consider during the sections where we have discussions, there's not going to be a ton of slides, so there's a little white bar, so slide that down, and it'll minimize the slide and maximize the people talking if you want to see us a little bit better. I think that's it. I think that's wrapping up our logistics. So again, welcome. Just real quickly, for those of you who don't know, Second Nature is a Boston-based nonprofit. We run a network of higher education institutions that have made commitments to climate action, specifically to carbon neutrality. And we have about 450 schools here in the U.S. that have a carbon neutrality commitment made by their presidents and chancellors. Been running this program since about 2007. So it's the largest and longest standing voluntary carbon neutrality initiative in the world in any sector. So really proud of that fact. Our mission is to accelerate climate action both in higher education and through higher education. Another way of thinking about it is that we think of campuses and higher education as a sector as both individual actors. So you can take action as a campus. These are large facilities we were talking about, and to decarbonize those facilities, you need to take individual action. And that's a lot of what we'll be talking about today, are those individual actions that campuses are taking. But then campuses also enable action. They have students, faculty, research, community engagement, connections to all sorts of options around the world that are not necessarily their own operational footprint. And so one of the things you'll hear today, hopefully, is the ways in which the educational mission, that kind of enabling function of the universities, can be combined with that acting function. So we have a whole set of assets at a university. They're pretty unique to the sector. You don't really find that in other places. And it's the combination of those two things that really is the powerful theory of change for us, that higher ed can be both an actor and an enabler of action. So as you think about the questions you have or your own situation, whether you are affiliated with a campus or work with campuses, I would encourage you to think about both of those pieces and not just focus on one or the other. With that, before we get into the substance, I want to turn it over quickly to Catherine Lubier, who is the Delegate General from Quebec in New York, and she's going to give a couple opening remarks. So Catherine, turn it over to you.
Yeah, thank you, Tim, for the warm welcome. And bonjour tout le monde, good afternoon. I'm delighted to be here introducing this important panel. Just putting this together, I've learned a lot already. And I want to thank our partners, Second Nature and Ecosystem. And just a few words on Quebec in this context. So we've been a long-term and active member of the climate group. We also share an ambitious climate agenda as a province. And again, this year, we're very, very proud to be at Climate Week. We have several panels this week. And since taking my role as Delegate General, I've pushed a message to businesses, cities, and communities that Quebec is really a true partner in decarbonization in the Northeast. Not only because we have a growing cluster of innovative companies such as Ecosystem, who does business here a lot in the US, but also companies in electrification, clean transportation technologies, and that's doubled by a commitment to export clean hydropower to New York. So that's why we think we're very well positioned to be a partner to reduce pollution. Now to the panel. So New York City buildings have been facing new requirements, I would say with a very ambitious agenda. And as owners and managers respond to these greener imperatives, including from investors with stringent ESG requirements, as well as with the recent legislation by Governor Cuomo, the Climate Mobilization Act, they face all kinds of challenges. And so today's status quo with steam heat systems are not only over-designed to maintain occupant comfort, but they're also costly to maintain and difficult to convert to low carbon heating. The electrification of heating is a surefire route to enable low carbon buildings, led by heat pump strategies already proven in cold climates such as Quebec. And as they say, if you can make it in Quebec's cold, then you can make it anywhere. So using evidence-based case studies from higher education, this tremendous panel, extremely interesting, will discuss strategies and actionable plans on converting buildings to lower cost and lower emissions, electrified heat. Over to you, Tim, on this, and enjoy the panel.
Thank you, Catherine. Thanks for those words. And it's always, I think, interesting for us here in the U.S., and we're going to hear from a couple U.S. institutions, to know that these solutions that U.S. campuses are implementing are really sourced from all over the world, and we're not the source of those innovations. Oftentimes, there are other places in the world where even better solutions are found, and so we should be welcoming that opportunity. So I'd like to introduce our three main panelists today. Ruth Bennett is the Director of Strategic Capital Programs at Tufts University. Bert Bland is Associate Vice President for Energy and Sustainability at Cornell University. And JP Druin is Ecosystem Energy Services Project Development Director. So welcome to all of you. Marie Francoeur is going to close us out. So Marie, Claude, thank you for joining us as well. But I first wanted to start with Bert, Ruth, and JP, and just, given this climate of COVID here in the U.S., we have a variety of issues. We have an election coming up. How has your climate action planning and implementation been going in recent months, especially? How have you found the context to affect these decisions? Bert, why don't we start with you?
Thanks, Tim, and hello, everyone. Glad to be here. So we first started with our climate action planning in the year 2000 when we adopted the Kyoto protocols because of student protests that the United States didn't adopt them, but students wanted Cornell to. So then in 2007, we were a founding signatory to the Second Nature carbon neutral campus commitment with a 2050 goal. And then in 2015, we advanced that date to 2035 in recognition of the urgency of the action. So we've consistently reduced emissions from campus operations over that time. We're both technically on track, and we update our planning almost every year, or at least every several years, so that we have a roadmap for the next steps ahead. We're on track with a 35% reduction since our first inventory was submitted in 2008, with a 35% reduction of our Scope 1, 2, and Scope 3 emissions for community and air travel, which is what we committed to and what we still track as our baseline. We've done that through pretty aggressive energy conservation. We've grown 20% since the year 2000 and kept our energy use flat. We've transitioned from coal to natural gas during that time, and we have strong engagement programs. So I'm really thankful to the public commitments in Second Nature. That's really helpful. We've had actually four leaders, four presidents of the university since the first signatory in 2007, and it's been important to have something on record so we can keep coming back to them.
I see. Yeah, great. Ruth, how about you? Where's Tufts' journey been, and where do you find yourselves now in this context?
Yeah, thank you, Tim. So Tufts actually has been working on this since actually 1990, there was a Talwa document that was signed by the president of Tufts and a number of other university presidents, committing, understanding that climate change was real and committing to working to solve it. And then in 2016, President Anthony Monaco signed the Second Nature Commitment, and that's our current commitment to be carbon neutral by 2050. And on campus, we have an Office of Sustainability, which is a really robust office that works on the ground with faculty and students and staff. Tim, you were talking about sort of a university, and we're a campus, but we're also teaching the next generation and doing research. And that office is very engaged and involved in helping people on a personal level figure out what they could do, and also working with us in the operations division to figure out what we can do campus-wide to lower greenhouse gas emissions. So we did just finish a year's worth of work, just under a year, with ecosystems to figure out a roadmap to get to carbon neutrality. And I would say what's interesting is a lot of that report was focused on our current deferred maintenance and our current capital plan, and not creating this completely new thing with lots of new funding requirements. And COVID hit and the students went home, and there's a lot of financial impact to that last semester and a lot of financial impact now to stand up the university. And one of the ways that I see that we're able to still keep marching down this road towards carbon neutrality is that we're working within the plan we already had. We're working within our existing capital plan and deferred maintenance plan. So we're not sort of saying, oh no, we need tons of more money and we certainly don't have that now because things are so fluid. We're trying to stick to what we were doing and amend it so it's going to be able to reach our carbon neutrality goals.
Yeah. So kind of not radical shifts, even though you can still progress because you have this plan in place. Yeah. Great. Yeah. And JP, you kind of have a broader landscape lens here because you work with numerous universities, I'm sure. And what sorts of things are you seeing now, trends in the kind of in the sector side or on the solution side that people are really looking to during this time of COVID?
Yep. Thanks, Tim. Thanks for having us. We're really excited to be here. So as it was mentioned, Ecosystem, we're a firm that does engineering and construction. We're based out of Quebec. So we've had experience with dozens of electrification projects over the past decades. And it's really exciting to see all this trend in the US with leaders like Cornell and Tufts with such commitments towards decarbonization. So to answer your question, if there's like one thing that we hear is regarding on the topic of decarbonization, is that from our partners in North America, is that it's one thing to be able to decarbonize the electricity, but decarbonizing the heating and electrifying the heating seems to be really another type of challenge. So really want to highlight that it's a multifaceted problem. We're going to be discussing great solutions, technical and behavioral, in this panel. But I want to stress how this is a challenge that is. It's a big one because, I mean, transforming an entire campus heating infrastructure from the plant to distribution and all the way to the classrooms, it impacts so many people, so many stakeholders. It can cost a lot of money. So that's in a sense one thing that we.
Great. Yeah, and that's like you're saying, it's a universal, so it's shared across a number of universities, especially those. I mean, we're here in Boston. Cornell's up in who knows where. Aren't you a center of nowhere, Bert? Isn't that what you say in Ithaca?
Centrally isolated,
so
yes.
Yeah. So the idea of renewable thermal and the solutions around that, it's really, really important to tackle. So let's dig into that a little bit. I know, let's just talk about the innovative technical approaches that you're taking. And Bert, I'm going to start with you again, but knowing that a lot of these campuses, we always say you have to practice what you teach. You have to, if you want credibility with your students or your faculty or your staff, you need to really walk the talk. And Cornell's been doing this, really some innovative stuff for a long time since the commitment. And so I'd love to hear specifically, what JP was alluding to, Bert, around how you're thinking about this next generation of technology to get you to your decarbonization goals by 2035, which is pretty aggressive decarbonization targets. Maybe Eric, we can pull up that slide. Great.
There you go. Thank you. So we, in upstate New York, like we said, centrally isolated, pretty cold winters. We have a 250 major buildings, 15 million square feet, a district energy system, a legacy steam system from the 20s, a chilled water district energy system from the 60s, and we have a whole our own microgrid. So right now we're making all our heat and electricity from natural gas, and we want to by getting off that by 2035. So really, electrification for us is the same thing as stop combusting anything, natural gas or coal or whatever. So this illustrates our plan. It doesn't illustrate the bedrock of a plan like this, which is energy conservation. We really want to keep the amount of renewable, carbon-free energy that we have to produce to a minimum, because it's really a lot easier to save energy than to make it renewably. So this illustrates electric, cooling, and heat. So I'll start with the electric. To have carbon neutral campus with electrification, you have to have carbon-free electricity. So we've had since 1904 a hydro plant. This is the wind, water, and solar. So that's a little water wheel down there. We have a pretty deep gorge going through the plant. So we were lucky to have a 1.5 megawatt hydro plant built in 1904, which we are continuing to maintain, operate, and we're getting a 40-year new license from the Federal Energy Regulatory Commission soon. We've been building solar farms on our own property, third-party developers. So we've got 5 large farms totaling 28 megawatts at high noon, about 20% of our annual use. And we don't have any wind yet. We tried with a developer, and not in my backyard, kind of got shot down. But we're out now with a consortium of higher education in New York State. A lot of the SUNYs and several private colleges. We're going out for a solicitation, and the proposals are in. We have really nice responses for upstate New York wind and solar, and we'd like to get some wind to actually complete 100% of electricity for our campus. And that's underway, and we hope to have good news later this fall. The lake, so this is a deep lake source cooling is something you have to have a district energy system and a conveniently close by deep lake where it's always 4 degrees centigrade at the bottom. So we were, after the Montreal Protocol outlawed ozone destroying refrigerants, we transitioned to a direct use of cooled water from the lake in the year 2000. So we've been doing that for 20 years. And then the Earth's heat is our aspiration. Again, it's electrification. We'd like to bypass the heat pump and just use pump water around. Our plan B would be ground source heat pumps, but this is deep direct use of the Earth. So we've just received a $7 million award from the Department of Energy to put in a 2-mile deep borehole, test borehole, to see what the permeability and temperature is 2 miles down, and we hope to be able to convert our campus to low temperature hot water, which is already underway. All the buildings are being spec'd for low temperature hot water that are new. We're converting portions of our steam legacy distribution system to hot water, and maybe someday soon we'll have a functioning well pair to take deep direct use of Earth source heat.
Wait, and Bert, when did you make that decision on the low temperature, the conversion to low temperature? Was that part of a plan a few years ago, or when did that start to come about? Because I think Tufts probably has, and JP, you could probably speak to some of the low temperature conversions as well in other places.
Well, we knew that we had to get off steam. Steam's like, it's 350 degrees Fahrenheit, so you can't use much waste heat for that. So to get off steam to hot water was part of our original 2009 climate action plan, which we filed, for Second Nature's website. It was only over time, I think, that we decided we really had to drive to low temperature. So we're just building 750,000 square foot residential now. It's all for 130 Fahrenheit low temperature hot water distribution. So we knew we had to get off steam, but what temperature has sort of dropped over time to 130, where we're at now.
Interesting. That's interesting. So whenever there's opportunities that present themselves, I know sometimes you just want to take big chunks all at once, or think of it as a linear path. But when you bring a new building on, that's a time to start that conversion to something like low temperature.
Right
it's
now
great.
We're being very,
go ahead.
We're being very opportunistic, not doing a large steam to hot water conversion, but as you said, we're opportunistically chipping away at it for now.
Yeah. So Ruth and JP, you guys work together on Tufts plan, and thinking about this large scale conversion of your infrastructure. How did that planning process go, and what sort of technologies did you think about, or practices did you think about while that was happening? Eric, I think we're going to keep it on the other one first.
So we are doing it much more incrementally. I mean, we worked with ecosystems and also clearly came to the realization that the first thing we have to do is, energy conservation, because as you said, Bert, better to have, a lower need than to try to create it renewably. But then the sort of main overarching thing that we need to do is change our heating system. So we're on steam. It's an ancient legacy system. We're constantly repairing it. And the first thought was we're going to go, to hot water. But as we worked through what we have now, I mean, we have steam, we have some heat exchangers in buildings, so we have hot water in buildings. Ecosystems helped us to look at, there's medium temp and there's low temp opportunities. And so we're actually sort of stratifying our roadmap, which is we need to convert from steam to hot water. We're going to do that opportunistically. Whenever we do a renovation on a building, we're going to work to connect the central distribution system with hot water and not steam. But then there's also a building that's creating hot water, and can we use the medium or the low temp from the return of that building to heat another building? So we're trying to take every BTU that's generated and used and reuse it if possible. So we have, Tufts has actually a trigen engine, so we purchase gas and we use that to create steam, but we're also generating electricity. And actually just this past weekend, literally a couple of days ago, we finished connecting our central energy plant to the entire athletic district on the east side of our campus. And that's been one of our big plans in terms of electrification. So we're trying to slowly set up the prerequisites to be finally renewably electrified, so to speak, in the future, but we can't do that immediately. We're definitely not going to get wind turbines because we're like in the middle of a city, so that's not going to happen. But trying to set ourselves up so that we can, use more efficient heat distribution by using hot water, and also connecting our electricity engine to as many buildings as possible, because that electricity that we create on a trigen is much more lower carbon emitting than if we buy it, from the grid. So,
yeah. And that's great. I wonder how JP worked together in developing that plan with Tufts, and is that consistent, kind of both Cornell's process and then Tufts process? Is that consistent with other places you're seeing? And maybe touch on both of those things, both Tufts specifically and then the sector as a whole.
Yeah, sure. Yeah, there's a lot of similarities, Tim. Of course, every campus is unique and it's all custom solutions, but there's a lot of similarities. And one thing that's similar that I think deserves some focus and attention is the solutions in the buildings. So Bert, it was really interesting to hear about the generation and district energy solutions. I mean, these are crucial that they're planned correctly and take advantage of those resources that you have. But let's talk about the buildings a little bit, because what's interesting to notice is that from our experience, when we analyze the total capital investment to convert whole campuses to net zero or deep decarbonize, if we were to break down the investment in three categories, one being the work needed at the central plant, two being district energy, and three in the buildings, well, it's not uncommon that the building portion carries more than 30% of the cost. Of course, it depends on the campus and what's in the buildings. And that happens because often the in-buildings heating systems, components, they need to be converted, piping, coils, radiators from steam to hot water, or from, like we discussed, high temperature to low temperature hot water, and always to make it compatible with the low carbon strategies at the plant. And that can be very complex. So we hear a lot of universities who are saying, well, I mean, we cannot afford to spend that much money inside the buildings. Let's say there's a lot of steam or a lot of high temperature hot water. So what can be done? What can they do about it? And that's what we hear a lot. And the good news is that there are solutions that they may be less sexy than those at the central plant, but they're a big part of the puzzle. So they deserve our full attention. So I'll just mention a few real quick. One is we think that the building portfolio should be decoded early on and analyzed first as part of the master planning effort. That's what we did at Tufts, among other places, because a good understanding of the buildings, what's inside the buildings, will tell you how easy or expensive it is to convert them. And depending on that answer, that may put you on the track for one or another strategy of district energy or central generation. So the buildings really can influence a lot of what's coming up after. And the outcome may be...
JP, when you say decoded, I don't know what you're talking about. I'm a new person here, right? So what does that mean?
That means
that's an important step.
You look at the components, essentially piping, coils, radiators, heat exchangers. And are they designed for steam, for high temperature hot water, 180 Fahrenheit, or lower temperature hot water, more compatible with low carbon solutions? So that's what I mean by decoding. And there are ways to analyze that and extract the potential for a building and a whole portfolio of buildings on a campus. And so then there can be various solutions and strategies. You could decide not to convert your 30% most expensive buildings if you arrange a certain configuration of district energy. So closely analyzing the buildings first is, we think that's crucial. Another one is to be creative. When you've decided that one building needs to be converted, well, for instance, repurposing some of the existing piping, coils, or radiators, instead of replacing them without asking questions if they still have good life in them or not, can cut your costs by 50%. That wouldn't be exaggerating sometimes. So, or completely re-engineering an in-building system. So that's another thing. And last thing I'd like to touch on is energy conservation. Like Bert, you said, if you cut your consumption in the first place, not only you'll save on operating expenses, but it'll also reduce your capital expenses because the new system can be right-sized and smaller.
Great. So lots of cost savings based on a good assessment, a good analysis on a building-by-building basis, and then some staging after you do that assessment to make sure you're making the most efficient changes. Bert, that sounds consistent with what sorts of things you do at Cornell. Am I right about that?
Yeah, I didn't really talk much about that, and we're early days. JP's exactly right. We've got 250 buildings, and it's the new ones are easy. You spec them for 130 Fahrenheit, low temperature hot water. But all our buildings were designed to take in steam. Typically, there's a heat exchanger that makes steam to 180 Fahrenheit hot water, which is too hot, really. So everything JP says, I endorse as a problem we're starting to think about.
And most campuses are going to be in that dual. You're going to be building new buildings as well as trying to think about old buildings. I think that's probably one of the universals in most campuses. Let's shift gears a little bit and talk about a bit of a non-technical side, because the technical piece is really important, but then there's all this stakeholder engagement. We actually had a question about this where you have faculty and staff and students that maybe have no idea, especially JP, as you said, the non-sexy stuff is going on, like chillers and pipes and whatever. Like no one knows about that. It's not big solar panels in the middle of your quad, So how have you thought about, and Ruth, I'll start with you on this, kind of the change management side of this, and what ways did Tufts, recognize your institutional strength and then build off of that with all of the campus stakeholders that we've been alluding to in the past?
Right. So let me just say one thing, that the students at Tufts do know what's happening. They're extremely involved, and they are pushing us, which is great, as is the faculty. So they're pushing us along. But the specific stakeholders I want to talk about, which is a little bit in the slide below, is a year ago, before we started with ecosystems, we had sort of a preliminary planning about carbon neutrality and had student faculty involvement. So giving us their thoughts and us sort of doing a preliminary plan. So we tried to get feedback, and I will tell you the biggest thing they said was hurry up. Like, why is it taking so long? But then when we started with ecosystems, one of their main focuses was, let's talk about the folks, the staff at Tufts who have to do this, right? And so it's not just me in capital programs, but it's the folks in procurement. It's the folks in facilities who are going to fix and repair and maintain all this. It's the folks in finance. We never had reached out to finance to talk about carbon neutrality. And then we certainly had a number of meetings with the academics. So if you look at the slide, and I apologize, the last sentence under capital planning says leverage 5 to 10 year capital plan funding for strategic implementation. So those words are missing, but they're in our minds. So we really talked to each of these groups to say, we want to get to carbon neutrality. It's our goal. It's our mission. Here's kind of what that looks like, steam to hot water. But what do you need? What do you finance, procurement, facilities, capital programs, the folks who deal with the users in the building? What do you need to make that happen? And one sort of famous quote from our whole process was one of our main facilities guys who responds to cold and hot calls said, I need to be able to say to the faculty who's calling that your dean has agreed these are the set temperatures in your building, right? So to take the onus off of the operations folks and understand the university-wide commitment. So when we sort of had these meetings and came back to folks, we ended up creating, ecosystems helped us create a draft MOU between facilities and the faculty about how we would operate, manage these buildings. Or we talked about language for the procurement staff so that they would be able to put out the same language in their RFPs that was consistent across the university. And we talked with the finance folks about a life cycle cost analysis in trying to implement that all of our projects, when they start going through the process of, the scoping out of the projects, it's going to use a life cycle cost analysis tool to figure out what is the best solution for the entire project or for each piece of the project, not just on first cost, because everybody wants to lower the first cost, but for the life cycle cost. And the finance folks actually were on board. We didn't really know that they would be engaged, but they were very supportive and grateful to have a tool that we can both use. So that really helped be able for all of us to have the language that each group needed, so that we're not just sort of pushing this carbon neutrality plan on people, but they're coming and saying, here's what I need to implement it.
Right, and it's so important. It sounds like it's just a critical piece of engagement across those silos. I mean, this idea of an MOU with faculty is kind of a wild, it's a wild thing. But
we're
many
working
times,
on it. We haven't done it yet, Tim.
Yeah. Oh, okay, interesting. Well, we'll see how report back to us on that. But it seems like a really nice model for saying, let's have a shared understanding of how this is benefiting both of us. And Bert, I'm kind of curious at Cornell, how have you engaged with faculty, especially, but also students and other staff on your kind of change management side of things?
Yeah, leave that slide up from Tufts. I'm going to play off that to answer your question, Tim. Couple of things. Be bold, aim for transformational change, it says under academic mission. So I think you can see from our earlier slide, Lakeshore Schooling was very bold and got a lot of community attention. Earth Source Heat's very bold, getting a lot of community attention, which keeps us on our toes. But it also gets huge amount of faculty and student interest and really enhances our mission, our academic mission. So the other thing I'd like to point out on Ruth's slide is the triple bottom line. And right below it, it says mission relevant. So we've taken those two ideas and created a quadruple bottom line. So in addition to the well-known people, profit, and planet, we've added purpose, which is the academic mission. So this is really great stuff, Ruth, and thanks for letting me take a few points off of it. So the quadruple bottom line has been very helpful, and especially adding the P, academic purpose. So if a project or a carbon neutral campus initiative is not going to make it alone by just saving the planet or helping people out or single bottom line profitability. If we can get a hook into academic purpose, man, it's huge. And in fact, that's how we've gotten so far in earth source heat. And to that, point, we actually have a concept of the living lab. The campus is a living lab. So our facilities are all open for teaching and tours. Now they're open for virtual tours. We're trying to make up some lost ground because we can't take visitors in, but and for research. So we offer them. We work with faculty and students to have living lab, both teaching and research. And earth source heat is just, we wouldn't be doing it without the academic leadership there. Lastly, I'd say this year we finally got all incoming students, all freshmen who pretty much do what you ask them before they get here and get cynical to watch a 13-minute video about how Cornell is addressing the climate crisis and how all disciplines across the university, not just engineers and the techies, but social science and natural resources can play a part. And we got really high engagement with the incoming freshmen and really good feedback. Tim, if I have a second, or you can cut me off, I could give one example that I find very fascinating of the living lab, but it's a kind of a wonky example, so I'll let you decide.
Yep, great, go for it. Wonk away.
Okay. Okay. It has to do with electrification, and you can't mindlessly just say, okay, what's the electricity you're going to use for this electrification project? You got to think about it. So, working with our faculty, we've discovered that even though upstate New York has the cleanest electric grid in the nation as far as pounds of CO2 emitted per megawatt hour of electricity, because of all our nuclear, all our hydro, and actually some brought in from Quebec and Ontario, we are still at the margin natural gas fired. So new electric load put on the grid, the concept of marginal emission rate is actually 3 times the average. And I think that's just something that the faculty have really gotten engaged with, helping us think through. And it's a very complicated project, but we've gotten some clarity working with the faculty. Thanks for letting me tell that, Tim. And if anybody wants to talk about marginal emission rate, I'd be happy to take that offline or correspond on it, because it's a fascinating subject to me as an engineer.
Yeah. And JP, I guess I'm curious from your perspective, you've got all this intellectual horsepower on the campuses that you work with. I mean, they're not really taking your business, right? But they could complement the work that you're doing. And so what have you found on this kind of holistic way of engaging with campus to be most successful in the way ecosystem has, either through Tufts or other places, started to accelerate kind of these leading edge solutions?
Right. In terms of, stakeholders engagement and driving change, I think Ruth and Bert really stole all my answers. You really covered a lot of the great topics. But so maybe I'll say briefly that in engaging stakeholders, it's interesting how it often comes from different places. I mean, at a liberal art college we were in the Northeast recently, the key discussions were really driven by a sustainability committee with very engaged students, and they really influence a lot the decision making. At another institution on the West Coast, we were involved in a couple of years ago. The operation and maintenance staff had a big say in choosing one solution versus another because of the impact on operation, and then another one, the momentum was really gained by faculty. So it really changes, but I couldn't agree more with what was said on engaging stakeholders. And maybe another idea perhaps is there's certain policies and standards that can be adopted. It's interesting how creative that can be and rich of a topic that can be as well. For instance, like Bert, you said, new buildings, make sure they're built at with a certain standard of hot water temperature would be an example. Another university in the Midwest we're involved with, they adopted a policy that their entire building should see its energy use intensity reduced by a certain percentage by a certain date. And that's impressive how much change that can drive once that policy is adopted. And yeah, finally, I think Ruth touched also on the life cycle cost analysis tool. We see a lot of institutions adopting those tools to standardize their process, the methodology of developing projects, to take to account not only first costs, but all project costs. And that can help to build a case for decarbonization projects. If the tool is in place, it's adopted by all the people in-house, and it's a trusted tool. It can show that that a project that costs initial money can actually drive long-term value.
Tim, if I could,
such an important,
sorry, JP, were you
done?
done?
Go ahead, Ruth.
I just had a couple of comments. One is, so we are implementing this, as we speak. We don't have a final MOU with faculty and all that kind of stuff. I mean, there's a lot of change management that this slide shows and what we're working on, but this is not high cost. And in some ways, your first question was, what's the effect of COVID? Well, there's a, lot of financial impact to universities, but the stuff on this slide, the quadruple bottom line, that's low cost, work. And implementing that now, right? So we're sort of really geared up for whenever life comes back to normal, or whatever we define the new normal. But that's what's also valuable about this change management, is it sets you up for success, even if the dollars aren't there yet. Or, digging up your campus is really complicated from an operations point of view, but there's a lot to do to change how your projects are thought of, conceived, how they're analyzed, and how they're implemented for very little money. And that does change, ultimately, how much carbon your campus is going to emit.
Yeah, it's really encouraging to hear the very tangible things you can do in this time right now, and that those things actually set the tone for the long-term change. Whether it's a building energy efficiency standard or a temperature spec or whatever it is, like really critical to start on that stuff now. So let's just move to the last section here, and I would encourage folks, if you have questions, feel free to put them in the chat or in the question box. We've heard about both the technical side as well as the change management side. How would you synthesize these two? What are a couple key lessons that you would say would be transferable to really any campus anywhere? What are the top couple things when you think about, especially on this idea of renewable thermal or thermal decarbonization, which is kind of the sticky question for next level thinking. What's the big takeaways that you would have? Let's go, Ruth. I'll put you on the spot. Start with you.
Yeah. Well, we all said it. I mean, the number one takeaway is reduce how much energy you're consuming in the first place. But I think, incorporating it into our existing plan is really effective, right? We're not going to the trustees with a big new request. Even before COVID, that was not going to look too good. But it also lets everybody who worked on that deferred maintenance plan and that capital plan feel a part of the process. So we're not sort of saying, thanks for all that work you've been doing, and we're starting from scratch. So it's multi-layered, where we're taking what everybody's worked on and we're putting it through the sieve of carbon neutrality. We're not asking the trustees to look at a whole new, set of plans. And so I think the big thing is that, sort of psychologically, people feel like this is not, this is imperative and critical, but doesn't have to like turn the campus upside down. So I'll give you one quick story. We actually put in chilled water line from our central energy plant to about 4 buildings. And we spent literally thousands of dollars on signage, telling people where to walk, because we had ripped up the entire campus and you couldn't always walk from one building to the other building, and it was mind-boggling. But you see how complicated and disruptive that is. And so trying to take what we have and put it through the sieve of carbon neutrality, it comes out a little bit different on the other side, but it's recognizable. I think helps people feel like this is doable, right? And we can do this, and with some change management, you are doing this.
Great. Bert, what would you say? Top 2?
Thanks, Tim. So I think in the time of COVID, we don't know how. Basically, I just heard we had a workshop, the town hall with our senior administration, and we're redesigning a whole new university mode here. Even though Cornell is in-person residential this fall, we're hybrid, have in-person and Zoom classes. Everything is changing. You know, we're testing 5,000 students and staff a day for COVID, for surveillance. And so the finances of the university, starting back in March, April, were turned upside down, really. One, the uncertainty in what our finances are going through. So I think we have to recognize at this time that many institutions are very concerned about their economic viability. And the climate action plan has to be, we can't stop. It felt like just stop. You know, I was told, okay, we're not spending any money on anything except critical infrastructure that might, you know, have a safety thing. So that's where we're at today. So how do we can't stop. It's you know, the climate crisis is real, and our commitment still is to 2035. So how do we advance given the single bottom line focus on just being a viable economic institution and a safe one for the students? So we really want to talk about all the benefits that our climate action has, and there's many reasons just beyond decarbonization. You know, there's future risk to finances. So for instance, as we procure, we go basically long energy, as meaning we're investing in energy when we invest in wind, water, and solar. That offsets an exposure of natural gas here on campus that we're going to have until we decarbonize. So there's a cross commodity hedge there, and it reduces the risk to finances. Human health is big. So as we've seen both things going on. As we've been able to sell energy conservation projects that upgrade controls and allow for better ventilation, and that's the people part of it. So I'll go back to the quadruple bottom line. People really matter right now. The academic purpose still matters. The profit, or the single bottom line, is very important. And the planet, we just got to figure out how to take a little detour and keep progress going in this time. So that's my little, you know, we are stressed here, and we're just trying to, we don't want to, I don't think we can accelerate action, but we don't want to stop action. We want to keep momentum going.
Yeah, or do various things now that can set you up for success in more the medium term, and maybe take advantage of some of the things that, you know, not having as many students on campus, for example, you might be able to have some conservation measures. JP, what's kind of your big takeaway from this discussion?
I mean, we've touched on technical solutions. We've touched on change management. I mean, now here, Ruth and Bert, I mean, these times are really they've changed a lot of the, you know, the immediate plans, and we're really I mean, we think that we're really sensitive to that. So I mean, maybe thinking about the medium term plans, how to keep making progress once we find a somewhat of a normal situation. How to actually, I want to touch on something Ruth said, how to actually implement the projects, and Bert make sure that they're financially viable. So maybe one little thing I can touch on that hasn't been discussed so far is how to actually implement the project delivery method. And because you may have the right plan, you may have the right solutions, but you got to get it done right and on time and on budget and performing as planned. So from our experience, that's one thing that's easily transferable to other campuses. And so we all know the best path forward is to work with partners who share your commitment to end results. And one way to implement projects that we think has a great success rate is integrated engineering and construction. And we see a lot of momentum gaining in that regard for certain types of projects where it's more suitable to do the engineering and the construction in an integrated manner. And so that can be, perhaps help alleviate some of the stress on resources right now with COVID, and also making sure that projects are on budget, perhaps with when your partner can commit to project cost and performance. So that's along with some other advantages of making sure that nothing gets lost in the gaps of in between engineering and the contractor. So so that would be one last message that we can think of.
Great. So various different models of process. We didn't really touch on that much, but you found some of those to be successful in both performance and probably some cost savings there too. We do have a few questions here, so let me just get to those as we start to wrap up. And the first involves, we mentioned life cycle analysis, and of course there's different ways of doing that. But one person asked, do you include the social cost of carbon in that life cycle cost analysis? And maybe Ruth or Bert or JP, anybody can take that one. So how does the social cost of carbon factor into that LCA?
Go ahead, Ruth.
Okay.
I can get second.
Okay. I mean, so I would say it doesn't from a pure financial point of view, but it does in terms of how we look at everything we do on the campus. So we look a lot at the health of our students and our surrounding communities. I mean, we're in a very dense, pretty urban population. We look a lot at social justice and how climate change mostly impacts low income and communities of color more adversely than more affluent communities. So I would say truthfully, it isn't in the financial analysis, but it is in the overall analysis of what we're doing on our campus as a whole, because we really are within a much larger community.
Yeah. Anybody else want to?
So yeah, last time we really did a hard look. Like I said, since the president left, who moved our goal up 2035, we've had several presidents come in and say, well, what is this going to cost us, and why should we do this? And so we have done life cycle cost analysis, net present value, with a shadow price of carbon. We've used, so this was a number of years ago, let's say 4 or 5 years ago, we used, I think $55, which was sort of the social cost of carbon at the time. Lately, we're using $100. And again, it's a sort of a shadow to inform decision-making, not to dictate it. We're also using it on how we dispatch our natural gas turbines to make or buy electricity. So we're watching the carbon intensity of the grid versus the carbon intensity of ours, and we're using $100 a ton. And I guess I'd say when you do life cycle cost analysis, one thing I found over a long career is it's really hard to predict the future price of electricity or the future price of any energy, really hard. So we try to do a probabilistic view of the future, so that there's not just one answer. At least high, medium, and low. And the same thing goes for carbon costs. We don't know what that'll be in the future either. And someday it'll be real, especially in New York State. Yeah, it's coming for electricity.
Right.
There's a number of campuses that, yeah.
I was gonna say, well, we use, I think, the Obama administration cost of carbon, the same way you're saying it, Bert, that we use it while we're doing a life cycle cost analysis, just of the cost of the equipment and the operations. We also have on the side the cost of carbon. I think now that we've sort of completed this process and are in really engaging and implementing it, we're stronger, the capital programs folks, about using the cost of carbon, even if it isn't in the main analysis. We put it on the side, as you said, because we do believe it's true. We do believe there is social costs, and the inequities are real, and they actually are financially accountable. The accountants sometimes don't like to look at it that way, but it's our job to kind of keep bringing it into the conversation.
Yeah, I would
right?
agree with that. It's often something that we use, and actually because it's desired by our partners to be part of the process to evaluate different projects and compare them one against each other to support the decision-making process. Like Bert said, it's kind of a shadow cost, but it helps to compare two competing scenarios, and it's a smaller cost than other expenditure buckets, but it's nice to see it. It can make a difference.
JP, I'm going to stay with you on this one. The CapEx projects where you're investing and then getting a return in the future. How have you seen some creative ways to finance that, or do you have some things that come to mind as far as new instruments on the market for making that happen?
It's a good question. I mean, we're essentially ecosystem. We're not into the financing part of the projects. We do the engineering and the construction, but yeah, I mean, we definitely see some ideas here and there. There's energy as a service that's often popping up. There's ESAs, PPAs, other types of agreements. So yeah, I'd be curious to hear Ruth and Bert on that.
Well, I think times are changing. So like Lakeshore Schooling, when we built in 2000, Cornell University had debt capacity. So we just went out and borrowed $58 million. And, we're paying it off over 30 years. It's pretty low rate, but I think those days are over. I think public-private partnerships, third-party ownership, what JP called energy as a service, we're just going to have to go down that path. And in the past we've already kind of self-financed, but I think those days are over. So so we're trying to figure this out right now.
Yeah, I think the same. I mean, there are a number of organizations that are approaching us saying, the interest rates are low, we can finance projects for you. Similar to Cornell, we never really were doing that. We were borrowing against our own, operations. But I mean, I would say so many things are upside down in this time of this pandemic. That new financing, mechanisms that we wouldn't looked at before, we're probably going to be looking at now.
Yeah, just on our side, we're starting to convene some of the CFOs to have some of these conversations around what's the next level of finance, what sorts of considerations do we want to have. This is our last minute, so I think it's always appropriate to end with students. How have you seen student engagement work really well in kind of bridging this? You mentioned like students really pushing the institution to do more aggressive climate action. In what ways can students get involved in these plans or infrastructure plans that aren't, protesting rah-rah, but maybe even just like part of the implementation? And there's a role for both of those things, right? But how can you, on the kind of implementation side, where do you find the most benefit from working with students?
So I'll speak a little bit to, so the Office of Sustainability at Tufts has created a number of programs where students are involved, right? They are working in their dorms, they're working with professors. We have a new sort of wood frame house project where we have meters so that students can look at the energy that they consume. So I think part of it is helping them actually do, the analysis of carbon reduction, or helping them change their lives while they're on campus so they could take it with them. And the more that they know it, the more they ask their faculty about it, the more they ask their advisors about it. So it starts to shift the curriculum in the university. I mean, we always have sort of engineering students involved with us and environmental science students involved with us. But I think those students who are not involved, the students who are studying dance or, history, having them sort of incorporated into their lives has a big impact on what they're looking for when they're at college and then when they leave. So it's not so much are they, helping us figure out what our, LCCA is of a certain project. It's more about them doing it in, on campus and getting their friends and having fairs about it,
Great. Yeah. Yeah, go ahead. 1 minute, Bert.
Okay, it's just we have a robust bunch of clubs working on it, and I'm really excited. The thing I mentioned earlier that we sort of opened incoming students' eyes to they don't have to just be a technical person. That all disciplines can really contribute, and I think that's going to bear fruit.
Great, thanks so much. This is great. Marie-Claude Francoeur, I want to introduce you. She's the delegate from Quebec, New England, and she's going to close us out. Marie-Claude, floor is yours.
Thank you, Tim. Thank you, Tim, and thank you to all of our very enthusiastic panelists. This is great. It's very encouraging, not to say energizing, to witness the leadership role of higher education institutions in solving pressing sustainability challenges. As you've heard, Quebec is inventive, and the avant-garde energy cluster, of which ecosystem is a beacon, can provide proven solutions to help achieve ambitious and bold climate goals in higher education and other sectors of the economies. We're glad that some of our lessons learned can be helpful wherever you are in your path to decarbonization. Quebec has long developed policies that make it a leader on climate change and GHG emissions reductions. In addition to being a long-standing member of the climate group Under Two Coalition, Quebec was the first jurisdiction in North America to put a price on carbon in 2006. In 2013, we joined the Western Climate Initiative to establish an economy-wide carbon market with California. Quebec's abundant renewable energy resources allow it to be a partner with states across the Northeast seeking to reduce their own GHG emissions, and was recently dubbed the battery for Northeastern power systems by another fine higher ed institution, the MIT Center for Energy and Environmental Policy Research. Today's panel confirmed that regional partnerships at all levels are the path to deep decarbonization. Quebec and the United States should continue to leverage their mutually beneficial trading relationship to address climate change in an environmentally and economically sustainable manner, if only because climate change knows no border. Thank you.
Thank you, Marie-Claude. And thank you, Catherine. Thank you, JP. Thank you, Ruth. Thank you, Bert. It's really great to have this conversation. I think I know we're taking away a lot. I would say for the audience, we're happy to stay on for a few more minutes if you wanted to ask any questions. I think our friends from Quebec might need to move on, but feel free to put those in the chat, and we'll officially wrap this up as the formal program. But we'll stay on for about 10 more minutes if folks want to put any more questions on the chat. And so I want to allow people to be free to leave if you want. But I did have a question. Thanks, Catherine.
Thank you, everyone. That was fascinating.
Great. This kind of international component, I feel like we don't do that a whole lot. You know, we don't talk about it a whole lot. This exchange, the exchange of companies and businesses, and you know, it seems like such an opportunity to do different types of exchanges, whether it's research, students that go work at companies, you know, that might be overseas as part of an exchange program. You know, is there something there around climate solutions on the private side and international exchanges that we could be thinking about differently?
Yeah, I think you're right, Tim. That's something where we're starting to explore. To be honest, we have one research project going on right now with a Canadian university to explore new ways to analyze data to drive better energy conservation measures. But yeah, internationally, there would be a lot of benefits as well, for sure.
In our
I'm kind of curious. Yeah. Okay, go ahead,
in our pursuit of the earth source heat technology, we've got a really robust relationship with the professionals in Iceland. They have easy to get at geothermal. We have deep, cold, relatively cool geothermal, but we have a good relationship with them. We've been to also France, Paris, France, where they actually have a geothermal district heating system. So I think Europe is certainly, and I'm sure Quebec is part of that, is really been the leaders in low temperature hot water, and we're learning a lot from Denmark and elsewhere about low temperature hot water, because that's really the European model that we're following, I'd say.
Yeah, I mean, there's a number of engineering firms in Denmark that have kind of had an annual trip to bring folks from the US basically to understand what it looks like to have this kind of distributed, renewable energy. And that's very helpful. So it's kind of there a little bit, I think, in pockets.
Yeah, maybe we could think about a Montreal trip for our New England friends. Let me just get to some of these questions. So one person asked, what's the financial impact of the new framework at Tufts to implement the carbon neutrality transformation? So when you think about maybe the whole package and pricing that out, is that the way you thought about it, or yeah? How do you think?
Yeah, I mean, we did look at what's the impact on those projects that were in the deferred maintenance and the capital plan that we were going to do anyways, and that would have an impact on carbon reduction. It was about a 15% increase on that overall number, which actually is relatively low compared to like digging up our whole campus and putting in all new piping at every single building. So that's before COVID, that was definitely a manageable price. I think right now, it's kind of like Bert said, we cannot go backwards. We can't stop. We might be going forward a little bit more slowly and setting ourselves up for being really ready when things settle down. In my mind, 15% based on what we were going to spend compared to the operations, savings and the impact of climate on, we don't live in Texas and Louisiana and the West Coast, but it doesn't matter because soon it will be that way here in some shape or fashion, another Superstorm Sandy, and, we're all in that boat. So.
Right. Bert, one question here for you about future prediction. Maybe it's around like escalators or some sort of value, the price of carbon in the future. Where do you source that data from, and what do you use to predict the future prices when you do these life cycle analyses?
Well, for electricity, which is actually the big unknown, what's the price of electricity? And often as you electrify, and you're reducing, your electric use or using more, you want to know what the future price of electricity is. Ventyx, VENTYX, is a subscription service that is used actually by our consultant, the higher education consortium consultant for our renewable electric energy purchase. So and again, it's very probabilistic. Let me just tell one anecdote really quick. So when we did the economics for lake source cooling in 1998, we said, okay, it's going to use only 1/10 the amount of electricity that conventional chillers would. So we said it's going to cost twice as much though. So all the savings are based on future price electricity. So we did a probabilistic future look at that, and we said the high cost, it'll never go above this price of electricity in the next 20 years. It'll never go below this in the next 20 years. And now 20 years later, it's gone above what we thought it would, and it's gone below what we thought it would, mainly because of fracking. But anyway, I hesitate to predict the future. I'm very cautious. It can't be done. Just do a range or a probability density function if you don't want to just do high, medium, and low.
Yeah. We had a question here about Canada and district heating initiatives there. Maybe JP, you could speak to that. Any interesting work being done in district heating in Canada that you know about?
Yeah, I mean, there's certainly a few. I think it's fair to say that Europe is in advance in terms of district systems. I mean, Denmark was mentioned. They really have it's more part of their I would think their culture and the reflexes to build large district networks, low temperature networks. But in Canada, one that I can think of, well, in Quebec, first of all, there's a lot of electrification because of low prices of electricity. So that really drove the market. That's what we've been doing a lot for the past 25 years. Most school districts have gone through at least one stage of electrification, not necessarily 100% electrification, but at least some base load of heat pumps, and same for hospitals, some universities, and it's starting to penetrate some other markets. But in terms of district networks, well, I can maybe speak to one that I know a little bit better. It's in the city of Montreal. It's there's a complex that's owned by the city of Montreal where there's the Olympic Stadium that was that dates from the 76 Olympics, and also has the Biodome, which is an indoor zoo with different ecosystems. So that's a project we've made in multiple phases, and so that's a not as large of a campus as some of the higher education campuses are, but still has a lot of interesting components with heat recovery from the Arctic zone and heating the tropical forest, and also the Olympic Stadium with a rather large-scale conversion and heat pumps. As a matter of fact, we have a virtual tour coming up on October 7th. So if you're interested, you can reach out to me. So yeah, a few district projects.
You forgot the best part of that complex. It's the insectarium, that place where all the insects are. That thing is amazing.
Oh yeah, you've been there, yeah.
Yeah, it's great. So the last question here, I think it's trying to really get into how does the academic side of the house truly integrate into the carbon neutrality goals. And so whether it's the curriculum or research or internship, student activity, and maybe I'll speak a little bit to this and then hand it off to Bert and Ruth, but the idea that you could have a more full integration between, you talk about campuses living lab, but how does that actually inform the next large decarbonization project you might produce? I know we see it in a number of campuses across the U.S. that there is a huge push in not just the hard, like the engineering classes or design classes, to actually do the installations themselves as part of just experiential learning. That's a critical part that's been going on for a while. But then also, could you redefine what it means to be a research institution? The University of California, Cal State system, and the community college system actually developed a whole research agenda around decarbonization for the state of California and their own campuses. They've done things around biogas, for example, or carbon pricing, and these are just fully integrated into the research questions. And so it's kind of we call a demand-driven research model. Instead of the researchers themselves just coming up with ideas, they're actually addressing the climate needs that a campus might have, and working specifically with those academics on your campus. It's a relational thing, and I would take your point, Ruth, about how important it is to keep this relationship established from the very beginning. Whether it's through an MOU or just through intentional outreach, it's really a critical part of not siloing off that part of the house even further. But Bert or Ruth, do you have any thoughts on that curriculum research integration into the operations anymore?
Yeah, so we have a center for research called the Cornell Atkinson Center, and they have an environmental division, an economic development division, and a energy division, and they're really focused on climate, all of those, as you can imagine. So they have a pretty good endowment, so they're able to actually have a rapid response fund. If there's let's say maybe a grant coming up or area that's prime for research, they can seed it, get the faculty up and tuned up so they can have maybe a successful grant application. They're pretty good at that. And the last thing I just say is we just created a new whole governance structure at Cornell called the Sustainable Cornell Council, and it's got 3 committees, and one of them is education and engagement, and it's chaired by our dean of undergraduate education and our dean of vice provost, and the vice provost for engagement, and so they're really on it, this education and curriculum. So yeah, I think there's got to have some institutional structures to make that work, and we do. I'm happy to say.
I would say, I mean, I'm sure there's more at Tufts than I know about, but I'm thinking out on a smaller scale. So there's like a green grant fund for students and staff and faculty to apply for funding for, you know, small grants for creating projects. And I think part of what that is, you know, students can work on their own, they can work with the faculty, and it happens twice a year. I think it's run by the Office of Sustainability, but it's trying to bring it down to, so I think Cornell really has an amazing governing structure in that sense. What I know about is sort of much, you know, on the lower level of students themselves, faculty themselves getting a $10,000 or $20,000 grant to do a research project. So there's like a couple of solar panels on the side of a building where you can charge your cell phone, right, which was a student project. And so again, trying to have the students actually do it, right? I mean, students are there for 4 years, you know, maybe a few more, but the faculty are there for longer, and trying to like get the students to be engaged in it for real when they're there for that short amount of time, while there are like, I think dozens of faculty at Tufts who are researching, you know, climate change and all the different ways of decarbonizing and you know, lots of different exciting ways. But I think one of the ways to make it real is to have the students be able to do something about it, you know, in their curriculum, in their research, in their club or activity when they're there in those 4 years. So I think it takes both. I mean, I think, you know, we do have a sustainability council at Tufts, and it has faculty, it has administrators, it has a student from the Senate on it. And that's kind of a much more larger overview, maybe not as well planned out as what they have at Cornell, but a similar concept. But it also happens, you know, it's from the top and from the bottom.
Great. I know we're out of time here, so I just say we'll follow up with everybody here who logged in and registered, and we thank so much the attendees for listening. If you go to secondnature.org, we have actually a climate solutions center, and there's a lot of examples that are either similar to what has been described here, or with other campuses, or even topically some other areas that we didn't touch on today. So feel free to do that, and we'll be back in touch with everybody. Thanks so much. Thanks to the Quebec government for helping with this, and for Ecosystem for supporting it, for Tufts and Cornell for being here. With that, we'll say goodbye to everybody. Thanks so much.
Thank you. Bye.